right, so for our circle unit that we're starting today, the very first lesson is most of it stuff you've seen before. I think there's like one new vocabulary word, but most of it is stuff you've seen before. We are going to talk about segments and circles. We should already know that a segment consists of all the points in a plane, so a flat surface, right? So not a sphere, not three-dimensional, in a plane that are a given distance that we call the radius from a given point that we call the center. So think like a hula hoop, right? Your circle is just the outside edge. The inside part of the circle, we don't call that part of the circle. That's actually called a disk, the inside of the circle, okay? So the actual circle itself is just like the perimeter portion, which is the outside edge, and then the center, okay? A segment or a line, we're going to just talk about segments today, but eventually we'll talk about lines, can intersect a circle in several different ways. The first one you should already be familiar with. If I have a circle, that means it's every point that is equidistant from a center. We know we can draw a segment that has one endpoint at the center and the other endpoint on the circle. What do we call that segment from the center to the edge? That's the radius. And all the radii are the same length in one circle. Usually you'll see us use the little letter R. Okay? A segment with endpoints on the circle, so if I draw a circle, and if I draw a segment that has both its endpoints on the edges of the circle, do you know what we call that? A diameter? Is this a diameter?
No.
Why not? The diameter has to go through where? The center. But this does still match the definition, right? It's a segment, and both of its endpoints are on the circle. So this is not a diameter. This is a new word for us. It is called a chord. It's a chord. Now, if you have a chord, and your chord passes through the center, so if I have a circle, and my chord goes through that center, so both its ends are on the edge of the circle, but now it goes through the center, this special chord has a name, and that you already know is this one's the diameter. Okay? And then we just remember that a circle has a radius and a diameter. The following things are true. Your radius is the same as the diameter divided in half. Or you can say your radius is 1/2 times the diameter. Or you can say the diameter is 2 times the radius. So depending on what you know, is which of those formulas you would want to use to convert from radius to diameter. Okay? Using this picture here, we want to list the shown chords, the shown radii, and the shown diameters. So let's start with chords. What is a chord that is shown in this picture? EA, capital E, capital A, and it's a segment, so I'm going to put a segment bar over it. That is a chord. Is that the only chord in this picture? Which else is a chord? DB is also a chord. It's a special chord, right? But it is a chord. Could I have written these as A, E, and B, D?
Yes.
Yes, I could have. But I do need to use capital letters, and I do need to use segment bars. Correct notation is important. Okay? There are other chords in this picture. They're just invisible, right? And I said I wanted to list the shown chords, but segment ED, if it was drawn in, that would be a chord, right? Segment EC is a chord. Segment AC is a chord. Segment BC is a chord. Segment AB, segment, pretty much any two of those letters that don't include F, right? Could be a chord if you drew them in. These are the only two that are shown in my picture. Okay? All right, radii in my picture. How many radii do you see in that picture?
3.
3, right? I've got the one that leaves F and goes to D. It's a segment because it's a radius. I've got the one that leaves F and goes to C. I've got the one that leaves F and goes to B. Those are the shown radii in that picture, but I could also go F to A, that's a radius, and F to E, that's a radius. It's going to be real common a few times in this unit that you'll need to recognize that you can draw in your own radius to be able to do the math involved needed for the problem. Okay? So it is important to know that FE is a radius, FA is a radius. Could I switch the order? Could I say DF, CF, BF? Yes, because segments, it doesn't matter which you start with. Only rays does that matter. All right, diameters. How many diameters do we have in this picture? One, and what do we name it? DB or BD, whichever one. Okay, make sure you're using all capital letters. Make sure you are using the segment bar. Okay, that is the only shown or not shown. There are no not shown. That's a weird sentence. There are no unshown diameters in this picture, okay? Because there's nothing directly across from E or A or C. And you really kind of need them drawn in because it's hard to tell with the naked eye whether or not something is directly across from something else, okay? So your diameter is really going to be the only one that you really need to see in the picture to be able to name it in the picture. All right, 1 through 7, we're going to refer to this little circle at the right. And the first one is to name the circle. To name a circle, what did you say?
Harold.
Harold? We can't name the circle Harold. I like that though. But we have to use its notation to name it. So you know how when you name a triangle, you do the little triangle symbol and the 3 corners. When you name an angle, you do the angle symbol and just the vertex if it's all by itself, or the vertex surrounded by 2 ray points if it's not all by itself. But you have to do the little angle symbol or the little triangle symbol. We do a circle symbol when we name a circle. So we're going to do a circle with a little dot. And then we use the center to name it. It kind of looks like or, but we say it, when we read it out loud, we read it as circle R. And again, notice we use a capital R. You can name it either with the symbol circle R, or you can write it out circle R. Either one of those would be appropriate. You can't just say R, because R is just a point. You have to say that it's the circle with the center of R. If you have what are called concentric circles, do we know what concentric circles are? Like think about a target where it's one circle inside another circle inside another circle. So they'd all have that same center of R. In that case, we would want to say circle R with a radius of, and you'd have to give more information to be able to name that, to be a specific circle. Okay? All right, we're going to name some things on 2, 3, and 4 about the circle, and we're just going to name the shown ones. So name shown radii in the circle. What are my shown radii? RA, segment, RX, RY, and RB. Notice I used all capital letters and I used segment bars over all of them. We could have switched the orders and had AR, XR, YR, and BR. That would have been just fine as well. Okay? Name the chords of the circle. What are my chords? I heard AB. I heard AX. What else? YB. Anything else? XY. Name the diameters of the circle. AB and XY. So they get to be written in both places because remember a diameter is a special chord. So they get to be called chords, but they're special chords, so they're also called diameters. Okay. 5 and 6 both go with the same picture, but they're separate problems. So I can't use my answers for 5 when I get to number 6. Okay? So number 5, it says if from A to B is 18 millimeters, so if this whole thing is 18 millimeters, then find AR. 9 millimeters. Bless you. Now, this is quite common in geometry that we use one picture and ask several different questions about the picture. So we want to go in and either scratch out that 18, so we can start with a fresh problem, okay? Which is why it's always nice to use pencil in math. So that way when we go to number 6, we're not still thinking about those old numbers, because now if I look at number 6 has completely different numbers, because now it says RY is 10. And then it says find AR. This time, how long is AR? 10. So in the last problem, it was 9 millimeters, and in this problem, it's 10 inches. 10 inches is just shy of a foot, right? And 9 millimeters is just shy of a centimeter. It's tiny. Okay? And then the last thing I want to know is how long is it from A to B? 20. Notice on 5 and 6 they don't have segment bars. Remember, when you don't have the segment bars, that's talking about distance. How far is it from A to R? How far is it from A to B? So when you don't have the segment bar, that's when it's talking about the distance. Okay? All right, number 7, is segment AX congruent to segment BY? Yes or no?
Yes.
Yes? Explain.
By side angle side.
Oh, look at you using your triangle congruence. I'm so proud of you. Yes, by side angle side. Remember I said we studied triangle for so long because we are going to need triangles even in circles. We need triangles because I can see I have this green triangle here and I have this pink triangle here. And I know, because they're in a circle, I know that these are the same. And these are the same. But where did you said side angle side. Where's the congruent angle?
The vertical.
The vertical angle, right? So by side angle side, the two triangles are congruent. Triangle RAX is congruent to triangle RBY. So then if I'm trying to show that AX and BY are congruent to each other, well, they're both the second letters of the congruent statement. So they're in corresponding positions in congruent triangles. So by corresponding parts of congruent triangles are congruent. Cuddle puppies because they're cute. CPCTC. AX is congruent to BY. Questions? All right. So most of that was not new except for the word chord, and the next part's not going to be new either. You've all seen circumference and you've all seen area. The main thing that we do is we accidentally get them backwards. So make sure if you're not 100% sure which one's circumference and which one's area, when to use which formula, make sure you check your formula chart because you always have access, even on the test, to the formulas. Okay, so just make sure you double check it. Your circumference is the distance around the circle, so think like perimeter of the circle. And then the area is the filled in space inside the circle. There are two formulas you can use for circumference. You can either do pi times the diameter, or you can use 2 pi r because 2 radii make 1 diameter, so it's interchangeable there. Your area is just pi r squared. Okay? It is what it is. For this first example, the most important thing to realize is this word exact. This is something you're going to see a lot in this unit. They're going to be asking you sometimes for exact circumference and exact area, which means, it doesn't mean no decimals, it means no irrational decimals. So no numbers that go on forever and ever and ever and ever and ever. Because we know when we use pi is 3.14 blah, 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 right? It goes forever. It's irrational. And so when they say exact, that means you're probably still going to have a pi in your formula, because they don't want you to have any decimals that go on forever. And they also don't want you to round anything, because when you round, that's not exact, right? You can have decimals like a 0.5 or 0.25, but it needs to be something that it ends at that decimal, right? So like 5 divided in 2 is 2.5, okay? And it ends at 2.5. It doesn't keep going. But 6 divided by 3, nope, sorry. 6 divided by 2 is a third, or 2/3, right? No, 3 divided by 6. Let's do it that 3, hold on. 2 divided by 6 is 1/3, right? So that's 0.33333333. That wouldn't be exact. You need to leave it as 1/3. Hopefully that made sense. I used lots of numbers there. All right, so let's look at this first example. We want to find the exact circumference, and we want to find the exact area, and then we're going to round our answers, okay? So for circumference, I have two formulas I can choose from. I can either do pi d, or I can do 2 pi r. Since they gave me the radius, I might do 2 pi r. And then you can multiply your plain numbers together. So 2 times 13 is 26 pi centimeters. Now, if I try to multiply that by pi in the calculator, or even by 3.14, if I multiply by pi in the calculator, it's going to give me the big long answer. If I multiply by 3.14, that's a rounded, right? Because it's not 3.14. It's 3.14 plus all those other digits. So this is the exact answer. All right, so then to get the rounded answer, then I'm going to put it in my calculator with the pi button. I'll get that in a minute. All right, so the pi button in your calculator is down here way at the bottom next to the H. So right next to the H, you see the little pi button. So I'm going to do 26, and I'm going to press the pi button. Thank you. And it's going to give me lots of different little options there. You want to choose the one that's pi. Thank you. All right, so when I do that and I hit enter, it tells me to the round to the nearest hundredth. We usually round to the thousandth, but I'm going to follow direction, and I'm going to round to the hundredth. That's 2 places, right, because it's tenths, then hundredths, then thousandths. So 81.68 centimeters. That is going to be my rounded answer. Okay? We're going to do the exact same thing with area. So for my area equals pi r squared. My radius is 13. So all I have to do is square the 13, and that will give me my exact answer. So my exact answer is 169 pi. Now, it's 13 centimeters times 13 centimeters, right? When you square it, you times it to itself. So 13 centimeters times 13 centimeters. So centimeters times centimeters. Area is always square units. Again, that square has to go on the centimeters. It can't go on the 169 pi. It has to go on the centimeters. This is my exact answer. And then to get my rounded answer, I just type it in the calculator. And we want the hundredths place, so area equals 530.93 square centimeters. Again, the centimeters squared goes on the centimeters, not on the number. Questions? Sometimes, occasionally, we'll work backwards. We'll be given either the circumference or the area, and we'll have to work backwards to find the diameter and the radius. So find the diameter and radius of a circle with the given circumference. Okay? So I know that the circumference, we find the circumference by doing either pi times d or 2 pi r. I'm going to do pi times d. We could do it the other way around, but this is the way I'm going to do it. So my circumference, pi d, equals 40 inches. All I did was substitute the c with what it equals, right? Substitution. Okay? Then, if I want to solve this for the diameter, right now I've got pi times the diameter equals 40. How do I get rid of the pi? Divide it. It's just a number, right? It's 3.1 blah, blah, blah. You can divide by a number. So my diameter, if it wanted an exact answer, my diameter would be 40 divided by pi, and I'd have to leave it like that. But it doesn't say I need exact. It says I can round to the hundredth. So I'm going to do 40 divided by pi. And it says nearest hundredth, so that's 2 places, 12.73. My units here were inches. Now how do I find the radius? Yeah, just divide that by 2. So my radius equals, I'm not even going to retype it in the calculator because it's already in there. When I hit divide by, it says ANS, so it's going to take that last answer in the calculator and divide it by 2. And I get 6.37 inches. Questions? Okay. Same exact thing for number 2. For number 2, my circumference is pi times the diameter equals 15.62. How did we get rid of the pi in the last one? Divided it. So my diameter is equal to whatever 15.62 divided by pi is. 4.97 meters. And then my radius, I'm going to divide this by 2, and my radius equals 2.49 meters. Which one's the bigger circle? The first one or the second one? The first one? Do we know the difference between inches and meters? Yeah, the second one, right? This one's inches, and it takes in a meter stick. I have a meter stick right here. I don't think it has inches on it. Oh, it does. So it's a little over 1 meter is a little over 39 inches, right? So if I've got a radius of 2 and basically a half of these, right? That's going to be pretty big. Whereas the other one is only a radius of just 6 point something, right? So the other one is a small circle, relatively. And then the second one is a pretty big circle. So units are important. Units are important. All right. Find the exact. So we want to make sure we're looking at that word exact, which means no extended decimals allowed. The exact circumference and area of each circle using the inscribed or circumscribed polygon. You have to enunciate correctly on these words because they're scary sometimes. All right, number 5. I'm going to skip to number 5 because number 5 is the easier of the 3, and we're going to work our way to the harder problems. Okay, so starting with number 5. On number 5, I have a right triangle. I'm trying to find the circumference, which means I need to know either the diameter or I need to know the radius. What can we find in number 5? We can find the hypotenuse of the right triangle, right? I know I can find a hypotenuse. The diameter is the hypotenuse of that right triangle. And we can find that by in my square root adding the 2 legs squared. So the 12 squared plus the 5 squared. Okay? If I put that in my calculator, the square root of 12 squared plus 5 squared, I just get 13, which is good, because if I got a decimal that went on forever and ever and ever, it would no longer be exact, and I would have to back up and do something different. But we got lucky, and that's what we call a Pythagorean triple. 5, 12, 13 makes a perfect triangle. So this is 13. which means the circumference is easy because it's just pi times the diameter, which means my circumference is 13 pi centimeters. My area is pi r squared. What's my radius? If it's 13 all the way across, what's my radius? Half of that, which is 6.5 or 6.5. So I know that's a decimal, but it ends at 0.5, right? So we're okay. And if I do 6.5 squared, it's 42.25. And if you're not sure if that's what we call a terminating decimal, if you're like, oh, what if that keeps going on and on and on forever? You can always hit divide by 1, and it's going to take that last answer and divide it by 1. And you'll see if it gives you a really big long number over 1, then it's not terminating. But this is still just 42.25. So my area is 42.25 pi. It's area, so it's centimeters squared. All right, on number 4, we're just going to work backwards. On number 4, it's almost the same thing. I have that rectangle in there. So it's kind of going to be the same process, right? I've got 3 and 7. These are both going to be 3. So that means if I want to find the diameter, it's the hypotenuse of one side of that rectangle that's been divided by the diagonal. So it's going to be the 7 squared plus the 3 squared, which if I put in my calculator, the square root of 7 squared plus 3 squared. Now, let's see, is that exact? If I do divide by 1, notice it gets bigger, so it's not exact, which means I can't use it if I want an exact answer. Okay? So, since I can't use it, here's our next option. We have to do it by hand. 49 plus 9, the square root of 58. And then, if the square root of 58 is simplifiable, if there's any perfect square that divides into 58, so your perfect squares are 4, no, 9, no, 16 doesn't go into 58. After 16 would be 25. 25 doesn't go into 58. After 25 would be 36, right? 6 times 6, that doesn't go in. 7 times 7 is 49, that doesn't divide into there. 8 times 8 is 64, that's now we're too big. So there's no perfect square that goes into 58. So this is my diameter. That's what I have to use for the diameter. Okay? So my circumference is pi times the diameter, millimeters. When we write numbers, traditionally in math, we write regular numbers and fractions first. And then we write pies, and if you have any sort of, there's also another called E. If you have pies or E's, we won't deal with E's this year, then those go next. After that would be any variables, if you have X's or Y's or anything like that. And then the last thing you always write is your square root, which means I've got pi square roots of 58. This is already in the correct order. If you switched it around and said square root of 58 pi, it's not wrong. It's just sometimes when you write it that way, the reason we always put the square root thing at the end is so you realize that that pi is not inside the square root. Sometimes we get confused at what's in it and what's out of it. Okay? Still need to do area. Area equals pi r squared. Now here's the weird thing, because how do you get from the diameter to the radius? What do you have to do the diameter? Divide it in half, right? Divide it by 2. So the square root of 58 divided by 2 is the radius. Because remember, we have to be exact here. We can't have extended decimals. When you square a fraction, the square has to go to both the numerator and it has to go to the denominator. So this is really, let me zoom in. Oops. Screen cut off on us. I didn't get there fast enough. Okay, so this is really area equals pi times the square root of 58 squared over 2 squared. What happens when you square a square root? It cancels out. So in the top I just have 58. In the bottom, 2 squared is 4. So this is area equals, we're going to put our number first because generally we put numbers before we put pi symbols. 58 divided by 4. You can leave it as 29 halves pi millimeters squared. Or you could change it to, because when you divide by 2, you get a 0.5, right? It's not going to go on forever and ever and ever. You could change it to 14.5 pi millimeters squared. Both of those answers are correct. They're both exact answers. All right. Number 3. What do you think we should do first in number 3? Find the diameter, and the diameter is equal to the hypotenuse. Did you say 9, what? 9 square root of 2. How did you know it was 9 square root of 2? It's a 45, 45, 90 because it's isosceles, right? Because those tick marks tell me that this is 9 and this is 9. So it's isosceles, which means it has to be 45, 45, 90, which means leg, leg, leg square root of 2. My diameter is 9 square root of 2. If you didn't know that, you could still do Pythagorean theorem. You would do the square root of 9 squared plus 9 squared, which would be the square root of 81 plus 81, which would be the square root of 162, which when you simplify would simplify to 9 square roots of 2. Okay, so if you forgot your special rights, you'd get the same answer using Pythagorean theorem. Okay, so, but since we remembered our special rights, we didn't have to do all of that. All of this over here, we didn't have to do it. So pi square root, or pi times my diameter is 9 square root of 2. You can leave it like this, inches. Generally, numbers will go to the front. So generally, you'll see people write this as 9 pi square roots of 2. But since multiplication is what they call commutative, it doesn't matter what order. These are just 3 things that are multiplied together. It's pi times 9 times the square root of 3, or 2. So since all 3 of them are multiplied, you can put them in any order you want. And this is just standard and traditional. Okay? All right, so then we still need to do area. Area equals pi r squared. So if all the way across my diameter is 9 square roots of 2, what's only halfway across? 4.5 square roots of 2. So just like over here where when we square a fraction, if we square 2 things that are multiplied together, that square has to go to both the 4.5 and it has to go to the square root of 2. So this is really area equals pi times 4.5 squared times the square root of 2 squared. So this is area equals pi times 4.5 squared is 20.25. What's square root of 2 squared? 2, because the square and the square root would cancel out. So this is going to be 2 times 20.25 is going to be 40.5 pi. What are my units? Inches squared, because it's area. Questions on circumference or area? All right, your assignment is available for you in Schoology.